Welcome to this video on AI-based cognitive research on textual documents through vector embeddings technology. In this video, we are talking about how a large language model works. And in the upcoming videos, we will discuss the introduction of the topic of AI-based content vectorization. We will talk about the new ways of searching and visualizing data that come from this technology. Let's start with the presentation of how a large language model works. We can say that a large language model can be considered as a genius in a box. Among all the LLMs available on the market, in this video we will refer to those produced by the OpenAI company, and in particular we will talk about ChatGPT. So, let's get started. Who made ChatGPT? We already said it. It was OpenAI who started operating in 2015 and in the following years received important financial endowments. It all started with the selection of the data sources. Billions of documents such as books, scientific papers, data from social media, and other online documents were selected. GPT-3 was trained on a dataset called WebText-2, a library of over 45 terabytes of text data. Many other data sources have been added, related to conversations between people, in movies, and technical support chats and others. ChatGPT was also trained on a large amount of unstructured data found on the internet, including websites, ebooks, and other text sources. This allowed ChatGPT to learn about the structure and patterns of language in a more general sense, which could then be fine-tuned for specific applications like dialogue management or sentiment analysis. It then began the data selection phase, starting from the available data sources. And it proceeded with the subsequent data ingestion phase. From all those billions of documents, all the texts were extracted, which were divided into sentences and then into words. All those sentences and words were then subjected to a deep learning process that lasted for months. From a technical point of view, we know very well what happens during a deep learning phase. What data scientists still don't understand, and this happens for every AI technology based on neural networks, is explaining why a neural network actually works, even though it works very well. And here we come to the final output of this process. A huge dense network made of trillions of chains of phrases. The transformer architecture is a type of neural network that is used for processing natural language data. A neural network simulates the way a human brain works by processing information through layers of interconnected nodes. Trillions of chains of phrases have been processed by AI. Let's take an example of what an LLM can do. For instance, let's take the beginning of a sentence like "How are you?" If we reflect on how this sentence could continue, there are actually many possibilities, but some have a higher statistical probability. And the main capability of a large language model is only to complete sentences. That's all, folks. In a LLM, sentences are divided into smaller parts called tokens. This is done for statistical reasons. All tokens are organized in chains where each token knows the statistical probability to be the next one in a phrase. And a LLM is simply very smart in predicting which is the most probable next token that will follow the previous ones. We cannot overlook an important critical point of this technology. In fact, the biggest trouble for an LLM is that once it starts an answer, it will always come to an end. This could cause inaccurate answers or completely wrong conclusions. This problem is known as hallucination. How to mitigate this risk? To partially reduce the hallucination problem, some humans were involved in the fine-tuning of the model. But how have humans improved the reliability of this technology? Some humans posed questions to the model, some simple, some complex, others ambiguous. They waited for the model to produce its response. Then they validated the response, deciding if it was right or wrong from a point of its correctness and its ethics. Incorrect answers were sent back to the model for a new round of fine-tuning, while the correct ones were accepted and validated. And so, barriers were created, so to speak, a box was built around the model. So humans have helped the model by simply creating ethical boundaries and correcting wrong answers. And so, the genius ended up into the box. We have reached the end of this video introducing the world of large language models. To learn more about how to leverage the computing power of a large language model to perform content-based vector searches on large knowledge bases, watch the next video in the series, which introduces the topic of vectorization and vector searches. Thank you for watching this video. All the functions that have been described in this video are available in our application BoK, Branches of Knowledge. To request a demo, click on the below link.